Welcome to ePathshala lecture series in computer science, and this is a course in cloud computing. We today will be continuing with our discussion on SOAP based web services, and then we will look at the next type of web service, which is the REST based, or as it is popularly called, a RESTful web service. We will compare the two types of web services, REST and SOAP, and also at this point in time we will look at what are the typical cloud mechanisms that uses a RESTful web service, followed by summary. So, what are the in the web services architecture, what are the in the SOAP based web services architecture, what are the different roles of the different mechanisms that exist. One is the service provider, the second of course is the service requester, and the service registry. This simple three-way mechanism with the help of the other standards creates what is known as a SOAP based web service. So, the first mechanism that is used in a SOAP based web service is the WSDL. In the last module, in the example, we saw the use of a WSDL mechanism. This is nothing but web service description language. This is a descriptive way of documenting your requirements. So, this is also part of the XML technology, and it is a standard for interface description. Essentially, it provides a set of rules that will bind how a service provider and a service consumer interact with each other. This standardizes the representation of how a service can be, an input and output can be invoked inside the web services component. So, the structure of the function, the method of invoking an input or output, and the protocols using which it is bound. It allows an easy, therefore, the machine to machine interaction is so easy and highly possible. The next mechanism that is used is called SOAP, which is Simple Object Application Protocol. In SOAP, this is a lightweight protocol for exchanging of messages. So, we have the messages. The mechanism of exchanging the messages is the SOAP mechanism. This provides the standard packaging structure for transporting. So, we use the XML documents. So, XML documents are do not create any confusion when one reads the document as to what is meant by a certain sentence or a certain line. Now, these documents have to be transported across the network for bringing the document from the one user to the other end of the user. So, this is done using SOAP. It defines how to encode, how to bind, and how to connect to a certain endpoint in the network. Again, this is RPC based, and we have seen in our earlier mechanism how easy it is for an RPC based system to work. Because SOAP is RPC based, the ease and the standard of the mechanism is very good. The third component of our SOAP based web service is UDDI. This is Universal Description, Discovery and Integration. This basically is a registry that is supported and that in turn supports the user and the requester and service requester and the service provider. Searching the finding or the discovery of the service is very easy using such a mechanism. We use the names or identifiers, categories, or some other specification and search the mechanism. A quick comparison of this can be in real life. We use a newspaper as an UDDI registry. We use insert when someone has something to be sold, we insert an advertisement in the newspaper, and seeing that advertisement, others will be able to contact us for those who are interested in buying the particular commodity. It works quite in a similar manner. So, it provides a structured representation. It will give the business relationship, the specific web services, the access points of how to do it. So, this is our service oriented architecture. We have already seen a SOAP based service oriented web service, where we have the registry, the requester and the service provider, and we have the technology stack, where we have the UDDI or the registry, then we have the WSDL descriptive language, then we have the protocol, which is the SOAP protocol, and the XML, and of course, we have the network at the end of everything. How they are related? The finding of a request happens using the UDDI registry and the descriptive language, as we saw. The publishing again happens between the provider and the registry using WSDL, and then the binding happens using the SOAP protocol. So, this is how a web services, a SOAP based web services does the work. Now, if we go back to what the types of web services we saw the one type was the SOAP based web service. The other type is called the resource oriented web service, or it is also called a RESTful Web Service. Data format will continue to be the same, XML, JSON, and even HTML can be used for either. So, the resource oriented architecture, the basic design principles is that there will be a set of resources, and these resources are such that they are of course computer storable and readable resources, and they are distinguishable from each other. So, the resource example of a resource could be a website, an HTML document or an XML document, an image, a video, some audio file, anything could be the resource. Now, in resource oriented architecture, we use the URI, which is universal resource identifier, and this will uniquely identify a specific location of a resource, and then this resource with respect to an URI will be the particular place and the specific file which we have to access. Typical example is an URI, where we have the location, the type of file and the specific file, and how to access that. So, continuing with our resource oriented architecture, the basic design principles is that it is we distinguish it from the SOAP based architecture, that this is HTTP commands are used for this. Typical HTTP commands are get, put, post and delete. There are a few. So, in a resource oriented architecture, this is a client, and this is where our services are located, and all the resources are also attached to the servers. Now, when the client requests for a specific resource, the resource is made available to the client by the service provider. So, the easiness, the less complexity, the simplicity of the mechanism is perhaps the most important part of this resource oriented architecture. It is called RESTful because it is representational state transfer, or REST. This is how the name has been generated. So, actually it is a doctoral dissertation of Dr. Roy Fielding in 2000. He proposed this simple mechanism, and this is an architectural style or a set of design criteria. This is not a specific standard. It uses many standard design principles. It works on HTTP commands. It uses what is called an URI. It uses the data format of all the possible mechanisms, which could be an XML, a JSON, any resource representation, all it can use, and it can further have texts or images as part of the exchange mechanism. So, any server having a specific resource can be accessed using RESTful. These are called RESTful Web Services. So, using RESTful Web Services, any server can be used. So, the ease with which the communication is done, no requirement of any specific mechanism to follow is perhaps the biggest strength of a RESTful web services. It will be using URIs, as we already have said. URIs are unique for a specific object. So, therefore, a resource attached to its URI is unique and can be identified using the HTTP commands. We manipulate the HTTP methods to identify a specific URI and use the same HTTP methods to manipulate or to get or fetch the specific request. The major advantage, of course, is that it is lightweight. So, what is the name? What does it mean? The client references the web resource using a URI. A representation of the resource is returned. So, how the resource is represented is returned. It is a sequence of bytes plus some metadata that will uniquely describe the bytes, and when the client requests or gets wants to get, they will update the resource. Again, a representation is sent to the client, and this brings the client to a new state. So, therefore, the client had a resource, it changes the state to get an update of the resource. Any hyperlink or a hypermedia selection will also bring the client to a new state. So, it is the representation of the resource that makes the client change the state. So, each time for each representation the client changes a state. So, how the resources are represented? A resource is the basic representation requirement has the resource. So, different resources have they may be some hence I decrease the network performance, and as we have been repeatedly saying that congestion in the network is one of the major problems that we face. So, also because of the statelessness, the server has no control. The server does not understand that it is the same client request that has come. Cacheable. So, what does cacheable mean? Client can store a request, some earlier response to a request. How is it done? The request, when the response to a request, when it is stored, it is given a specific level, and using that level a same response can be retrieved in the client side. This leveling is the problem of the client side, and it can be an implicit or a explicit level. So, what is the need for it? The client will be able to reuse a specific response multiple times. So, what is the problem? What is the good thing of being cacheable? As we just said, the statelessness creates an additional overload in the network. The cacheability reduces the need for the additional. So, say if it is the same request and the client understands that the request is the same, it simply caches the earlier response and uses that response. It will also be faster. Instead of sending a request and getting the response, if the response is available, it is a faster mechanism. What is the problem of cacheability? It is a problem that we face everywhere where we store the request, the reliability part of the response. If there is an update in the server side, if the request is coming after a gap in which the server got updated, the data got updated, then we always run the risk of using a stale data, which reduces the reliability of the mechanism. A simple solution to that is to keep some kind of a check or some kind of a understanding where we can refresh a cache every time there is a change in the server. There are multiple mechanisms available to ensure that this problem is not present in a cached environment. The next constraint is the uniform interface. This is a set of rules which decides the communication. As we saw in SOAP based, that the communication in a SOAP based communication, the protocol is very predefined. Here we have an uniform interface using which the this communication is understood. So, how is it done? It is HTTP. All HTTP predefined HTTP resource methods are used. So, the resource representation is, again we have a specific way of representing resources and self-explanatory answers, and of course, the hyperlinks or the hypermedia. These are the possible ways that uniform interface. So, here is an example where all the HTTP methods. So, we look at the first part, which is the URI. As we said, this is an uniform resource identifier which identifies the specific resource appropriately. Then we have get method which retrieves for a specific customer having a specific ID, it retrieves the specific data. Then we want to replace the data with something, then we say put is used for replacing the data. If that data is not existing, then put will create another data. Then we have the post, where post is used instead of put when the resource creator is not sure about the URI of the resource, and we have of course the delete, which deletes a specific resource. So, therefore, this creates an uniform interface and allows two ends to communicate without a misunderstanding. So, put and delete are idempotent operations, as we know that an idempotent operation is one where repeated use of the operation does not create a problem. Take the example of delete. If I delete a specific ID of 1, 2, 3, 4, 5 and then I try again to delete the same ID, already it is deleted, so no harm will come. So, even by mistake I apply the delete mechanism a number of times, there is no problem. Put and post are different, as in both are trying to create a new mechanism or update it. Only when the URI is not predefined or is not known to the user, then a post should be used instead of a put. So, why uniform interface is good? Obviously, the ease with which the uniform communication can happen. So, all the software engineering principles can be applied to this particular interface and simplification of the overall architecture. It becomes very simple and it becomes without any problem, it becomes easily the interaction can be done in a much easier fashion. The implementation is taken away from the services. So, since this is an uniform interface and specifically those many methods can be used, so whatever service we want to deploy, we can deploy and use the uniform interface to describe it. Therefore, independently various things can be evolved and all these can be used. Now, what is the problem of an uniform interface? The standardization, the efficiency of the mechanism may be degraded because it is very predefined and standard. The standardization causes, the simplicity causes the application to be constrained to keep things very simple. And the optimized interface again causes the similar kind of divided attention. More attention is given to keep that method simple and generic. Therefore, user specific or service specific mechanisms cannot be used, and therefore sometimes a suboptimal performance of a specific requirement goes. Layered system, each component is a layered mechanism. How it is used? Using hierarchical mechanisms, and the end server is acts as an intermediary. Why it is used? Encapsulation. I want to encapsulate every layer, and therefore I improve the scalability of the mechanism. What is the problem of a layered architecture? Of course, when there are many layers, the latency increases. And finally, code on demand. It is the functionality extended by the client. How it is done? Some codes can be downloaded and executed in the form of applets or some scripts. So, why is it good? Pre-implementation of certain features are not needed. Everything can be done by the client. The client design becomes simple because the code is downloaded by the client. What is the problem? The visibility. What is happening at the other end is not very clear, although code on demand is an option in the RESTful web services. So, these are the differences between REST and SOAP. We have, this is an architectural style, whereas SOAP is a standard, URI is the mechanism, whereas HTTP or HTTPS and SMTP are used. REST can use SOAP, but SOAP cannot use REST. Security mechanisms are predefined, whereas here security is inherent inherited from the underlying mechanism. Both can use different formats, but SOAP is constrained by XML, and this is a stateless. SOAP supports both state and stateless, and the rule is simplified, whereas it is harder to develop. So, for web services we have a good thing of using the REST, whereas for SOAP typical enterprise web services are what is good. These are some of the RESTful services used in the context of cloud, and we will discuss these in detail later on. So, to summarize this module, we looked at we have continued from the earlier module and looked at the SOAP based mechanism, how it works. Then we understood the meaning of what is REST, and then we looked at the REST constraints, and we have a comparison of the REST and SOAP. In the next class, we will look at the dependent technology, which is peer-to-peer computing. These are our references. Thank you.